So what we're going to start to talk about is some of the practice problems from Chapter 3. And what I want to start by talking about is checkpoint exercise 13. And exercise 13 asks us to do a couple of different things. It asks us to graph a few things and compare them with the original graph of y equals x squared. Now, from earlier videos, we know that looks something like this. So it's a matter of trying to figure out how this compares to the other graphs in the problem. And the graphs that it asks us to look at are the following. The first one it asks us to look at is 1/2 x squared. Now when we look at that, when we talked about this from Chapter 2, we talk about how this number here affects this graph. So if I make a coordinate or an XY table, I'm going to do this with all of these, and I'm going to show you how it affects every single one of these. And I'm going to have a very long table just because it's going to look a little longer than what you normally see. The normal graph, I'm going to just pick 0. If I square it, I get 0. If I pick 1 or -1, because of properties of symmetry, I get the same number back. And if I square -2 or a +2, I get the same number back as well. So there's my original graph here, and it grows at an exponential rate. Now, what I'm going to do is I'm going to show you how a new graph is going to look when I graph it differently. Now this one is asking us to compare with this if it was 1/2 x squared. Now the difference for this is that I'm going to take everything and I'm going to multiply everything by 1/2. Every number that I get, I'm going to multiply by 1/2. It doesn't matter what it is, it's going to be multiplied by 1/2. So this 4 that I got here, I have to multiply by 1/2. I'm still plugging in 2, but my answer that I got originally now needs to be multiplied by 1/2. So instead of 4, I'm multiplying by that by 1/2, I get 2. Because of properties of symmetry, this also has to be 2. Now, I'm going to do the same thing with the 1. I'm going to multiply those by 1/2, and I get both 1/2 for both of these. And when I get a 0 and multiply that by 1/2, I get 0. So my new graph has a point at 0, 1/2 here, and 2. So this graph, if I draw it correctly, still looks like a parabola, but it's a much smaller parabola vertically. So this one was shrunk vertically. So it was shrunk vertically. So that 1/2 took care of this, and it changed the way that it looked vertically by scaling it down by 1/2. So if you have a number in front of the square and all you have is a square, it changes it by scaling it down by that number. Now the same thing's going to happen if you have a number but it's bigger. Only the exact opposite's going to happen. I said the same, but I mean the same idea is going to happen. This is letter C. So now instead of having a 1/2 in front of it, I have 3/2 in front of it. So I'm going to take these original numbers here and I'm going to multiply them by 3/2. So I'm going to take that times 1 1/2 and I get 6. I'm going to do the exact same thing with this one as well. So I'm going to get 6 here. So at 2, it's going to go all the way up to 6, as it is with negative 2. And I'm going to do the exact same thing with 1 and negative 1. I'm going to times those both by 3 halves, and I get 3 halves. And lastly, I times this 0 coordinate for y by 0. I still get 0. So I have 0, 1 half, and a negative 1 half. So I still have this parabola, except it's now a steeper parabola. It's now stretched. Vertically. It's stretched vertically. So what you need to know is if there's a number in front of the square, if it's just a square and you have a number in front of it, if it is a number between 0 and 1, so in this case it was between 0 and 1, you're going to shrink it vertically by that factor. I multiplied all those numbers by a half. If it's a number that's greater than 1, it's going to be stretched vertically by that factor. So if the number in front of the square, I'm going to call it a, is greater than 1, it's vertically stretched. And if a is between 0 and 1, so a fraction less than 1, it's vertically shrunk. The book uses compressed, but it's also the same thing as saying it's shrunk. Now the last thing is if a is a negative number. If a is negative, okay, if a is negative, that number in front of the square is negative, you're going to take this whole thing here and you're going to flip it across the axis. So it's going to be a reflection. So it's a reflection across the x-axis. Okay, so it's a reflection across the x-axis. Now I'm going to look at another problem, and this is further along here. This is actually example 19. It says to sketch the graph of the quadratic without using a graphing utility. Identify the vertex, axis of symmetry, and x-intercepts. Okay, so I'm going to show you how you do that without even looking at a specific graph to do this. Now the first thing you need to do is identify where the vertex is. Now if you have a quadratic that is in this form, what you need to know is that the vertex is going to be at the point negative b comma 2a, and then I'm going to put in that coordinate for x to find y. So this just gives me a way to find the x coordinate. This just means you plug in to find y. So I'm going to plug in and find y. What I first need to do is I need to find out what a and b are in this whole thing. Well, this number here is a, and c is always a constant. So that's c. So we have a problem. There's no b. Where exactly is this b? Well, there is no b. So in this case, b is 0. B is 0. So it doesn't help us to try and say what b is. So I'm just going to say b is 0. So if I'm going to find the vertex, what we're going to get is negative 0 over 2 times 1. Again, 1 being this number here. So I'm going to get negative 0 over 2, which simplifies to 0. Now, in terms of how to find the y-coordinate, we now know the x-coordinate. So the vertex has the x-coordinate of 0. So that's what this means right here, that I just find the x-coordinate. Now I got to find the y-coordinate by plugging it in. Plug this in to find y. Well, the way I plug it in is that equation right here. So I'm going to plug that in and see what I get. So 0 squared is 0 plus 7, I get 7. So my vertex is at the point 0, 7. In terms of a graph, I know a couple of things right now. I know that the point 0, 7 is my vertex. The equation x equals 0 is my axis of symmetry. So I have those two things. I have my vertex, I have my axis of symmetry. Now I'm going to plug in a couple points so I can see an idea of what this looks like. If I plug in 1 into this equation, I get 1 squared plus 7, that's 8. Due to properties of symmetry, if I plug in negative 1, I get the same thing back. If I plug in 2, 2 squared is 4 plus 7 is equal to 11. If I plug in negative 2, I get the same thing back, which is 11. Now, if I look at a graph for this, you're probably going to look at this and say, well, how am I going to find the x-intercepts if I have a graph that looks like this? I have a vertex that's at the point 0, 7. I have 2 points that are at 1 and negative 1, 8. So I have this parabola that's going up. So the question is, how is this going to hit the x-axis? How can that hit the x-axis? Well, if I set this equal to 0, because an x-intercept is where y is equal to 0, I subtract 7, and what I'm left with is an equation where I'm looking for some number that when you square it equals a negative 7. Now, when we talked about this before, we get plus or minus the square root of 7i. So these are non-real. So there are no real intercepts. So there's no real intercepts for this.